Volcanic ash creates problems for air traffic and local residents' health. Being very abrasive, the ash in these clouds can stick to the jet turbines of passing aircraft and cause severe damage. To ensure safety, all air traffic within the area of the erupting volcano must cease until the ash cloud has completely dissipated. Currently, very little research has been made for measuring the behavior of these clouds and where the ash within them is the densest.
It seemed to happen in an instant.
The Alaska Space Grant Program is currently funding a research project conducted by electrical engineering graduate Russell Carroll to design and develop a UAV module that can observe the ash from volcanoes. This module will be equipped with an infrared camera with filters to account for various sources of radiation noise to capture a three-dimensional image of the ash cloud.
The first task was to design a simple assembly that could accommodate all of the components needed and any dimensional restraints. The parts that were to be built around are a camera, a motor, and the filter lenses. SOLIDWORKS was the preferred software and translates easily into the format that the 3D printer recognizes, and so it was used in the design stage. With this software, the lab bench prototype was designed to encase the camera and servo motor, as well as allow for the motor to rotate any of the filter lenses into position in front of the infrared camera. The simplest design requires the camera to be fixed while the filters pass in front of the camera lens. With multiple filters desired, a method of passing these filters remotely in front of the camera lens is required. How the filters can accomplish this was the focus of this project. There you go.
Do something, Ellie.
The current a little bit.
Way to go, kid.